Hey, and welcome to the lesson on isosceles and equilateral triangles. Our essential question and objectives: what are unique properties of isosceles and equilateral triangles? So we're going to list properties of isosceles triangles and list properties of equilateral triangles. Our standards: use congruence and similarity criteria for triangles and to solve problems and to prove relationships in geometric figures. Construct an equilateral triangle, a square, and a regular hexagon inscribed in a circle, and prove theorems about triangles. Theorems include measures of interior angles of a triangle summed to 180 degrees, base angles of isosceles triangles are congruent, the segment joining midpoints of two sides of a triangle is parallel to the third side and half the length, the medians of a triangle meet at a point. So we're going to actually be talking about the interior angles and sides of a isosceles and equilateral triangle. Our first thing we're going to talk about is the isosceles triangle theorem. It states that if two sides of a triangle are congruent, then the angles opposite to these sides are congruent as well. So that would be angle P and angle Q. So if you remember when we talked about isosceles triangles, we kind of stated this, but we didn't really talk about the theorem. We said if since angles and sides, since angles and the opposite sides of the triangles are directly related, that if two sides are congruent, then the opposite angles are congruent. But that was kind of just a property. Now this is a theorem that we can use in proofs. So if two sides of a triangle are congruent, then the angles opposite of those sides are congruent as well. So angle P is congruent to angle Q. So if we do the proof of that, we're going to let S be the midpoint, which means PQ is congruent to SQ, definition of midpoint. And then we're going to join R and S. So RS is congruent to RS. So PS is congruent to QS, RS is congruent to RS, and since we already know that PR is congruent to RQ, then therefore by side, that triangle PRS is congruent to QRS. And by corresponding parts of congruent triangles, that means angle Q and angle P must be congruent. So there's your proof of the isosceles triangle theorem. The converse of the isosceles triangle theorem is also true, which means if I see that two angles are congruent, so therefore angle B and angle A, they're congruent, then I can also say that their opposite sides are congruent. So AC must be congruent to BC. So if we look at this proof, an example you might see on a problem, it says, is AB congruent to CB? So AB and CB, are they congruent? Now if we use the converse of the isosceles triangle theorem, we can say since angle A is congruent to angle C, then the opposite sides are congruent. And again, that's the converse. So by the converse of the isosceles triangle theorem, therefore the opposite sides are AB and CB. They are the opposite sides. Therefore, AB must be congruent to CB. So yes, AB is congruent to CB. And finally, last but not least, equilateral triangle theorem. Now we discussed this when we talked about equilateral triangles, but this is just kind of formalizing what we talked about. If all the sides of a triangle are equal, then all of the angles must be equal too. So a triangle is equilateral if and only if it is equiangular. Okay? And then the second part of that, each angle of an equilateral triangle has a degree measure of 60, since all three triangles have to add up to 180, and since they are congruent, 180 divided by 3 is 60. And so the congruent sides of the triangle imply that all the angles are congruent. And since they are all 60 degrees, they are all congruent. Here's a look at your homework. You're going to review equilateral triangles and what exactly they mean. In identifying them, you're going to review isosceles and what that means. You're going to use that vocabulary to identify certain types of triangles. Then you're going to take on the theorems that we discussed in the video. Isosceles triangle theorem, the converse of the isosceles triangle theorem, things like that. And you're going to use those in problems to answer questions about certain triangles. So using the isosceles triangle theorems, looks like you're going to have to finish some proofs too, and a couple corollaries as well, and real life situations. So if you have any questions, don't be afraid to reach out to me on BBIM, email, text message, or phone call. I'll be in the Math Cafe at 11 a.m. Monday, Tuesday, and Wednesday. If you want to meet me there, you can also meet any teacher there. There's a teacher there from 9 to 3 every day. A math teacher is there to help you with whatever you have questions on. And also meet me in live class where we can discuss this a little more. Okay, and we'll see you later.